Hi, everybody. Welcome, one and all. Want to welcome you to this first in a series of webinars about HPC. Each time we're going to do this, and we're going to do this approximately once every month, we're going to welcome a special guest who has particular experience in the HPC space. We're going to take a slightly different angle each time. In this webinar here, we're starting in a fairly general fashion. We're looking at HPC immersion cooled, how immersion cooling applies to a HPC installation. We're going to look at the economics, the practicality, the challenges, the benefits, and more. And together with our special guest, Mr. Daniele Rispoli. Wanting to introduce myself here, very, very briefly. Yes, that is me looking a little tired there perhaps, but that's fine. My name is Diarmuid Daltoon. I look after worldwide sales and marketing for Submer. I'm a veteran of the hosting and cloud industries. I've worked with some of the largest hosting and cloud companies. I've always been somewhere near or next to a data center of varying densities, and you can always reach out to me here, as you see, by phone, email, Twitter, Insta, Facebook, LinkedIn, however you would like. Very happy also to take questions after this. I'm delighted to introduce Mr. Daniele Rispoli. He's our esteemed special guest for this session. And Daniele describes himself, and he's also described by his colleagues and friends as well, as the Mr. Wolf of HPC. This gentleman has roamed the world in the last 4 years, helping customers set up their HPC solutions from the physical hardware right through to the software layers. Daniele grew up and was educated in Italy. As you can see here by this picture, he sports quite an impressive beard. He frequently gets stopped at airports. And from what I can tell, for 3 or 4 conversations to date, he's an all-round good guy. So Daniele, welcome.
Thank you. Thank you very much for the excellent introduction. And thank you for having me here.
Daniele, I just wanted to ask you, is there anything that I've maybe missed regarding your introduction? I wouldn't mind if you explained this Mr. Wolf business to us. I get the reference, but maybe not everybody here in the session.
Sure. So the reference comes, of course, from one of Quentin Tarantino's most famous movies, from Pulp Fiction. And there's this guy that basically gets called to solve a problem, and he shows up in less time than he anticipated, and he finds creative solution trying to figure out, well, in that case was trying to hide a murder, but we're just restricting ourselves to HPC in this scenario.
Okay, I'm sure there's some dark skeletons there somewhere in your closet, but we're not going to go there today.
As you mentioned, I'm already going to get stopped at the airport as it is. Let's not go into the dark skeleton affairs.
Daniele, how did you get started in HPC?
I did get started in HPC by joining one of the Formula One teams. It's called still Scuderia Toro Rosso, and I was helping the CFD department there, taking care of everything that had to do with the aerodynamic of the car. And that, of course, required also writing code for their HPC solution and administering it. That's where I got started.
Okay, cool. What's your experience with immersion cooling in particular to date? As you know, Submer is all about immersion cooling, and this here is about HPC immersion cooled. So what experience have you got, and what HPC installations have you interacted with that were immersion cooled?
Yeah, I got the very fun task of supporting the Vienna supercomputing cluster number 3. That's almost 2,000 machines all completely submerged in oil. And then I also got to build a couple of clusters in UK with the same technology.
Thank you very much. We're going to get started here just on the main part of this presentation here. And then Daniele, of course, please jump in with any commentary. It's you who's adding the very great value for everybody here today, especially with all of your experience. But I'm sure after I get through some nice blah blah, we'll have some good stuff for everybody between us.
Sure.
So with the traditional data center market, densities look a little bit different than HPC. And I think, you'll agree, Daniele, but the point is that the average rack density that we're seeing in standard data centers, it's around 7 to 7.5 kilowatts per rack, but it is growing slowly. We know that in HPC, this looks a little bit different. Rack densities of 30 kilowatts are not uncommon. This is an image of a supercomputer, which I'm not sure if some of you are familiar with, but anyone who ever comes to Barcelona, I can only recommend, try and book a tour of the Mare Nostrum 4. It is a 13.4, 13.7 petaflop supercomputer. And I know that in parts of it, at least, they are reaching 30 kilowatts per rack as a rack density. This is by using a mixture of technologies, but let's not quibble or get into it. But Daniele, maybe just from your side, what's the most beautiful HPC installation you've seen, and what are the kind of rack densities and trends that you have seen?
Well, I didn't have the good chance to go into the Mare Nostrum cluster yet. That's something that's on my bucket list, my HPC bucket list, let's say. I have seen some pretty good installations in the Nordics. And the Nordics are probably the one that took better care of their machine rooms. There was one in particular, it was in Norway, a city called Ålesund. And the whole data center was just excavated into a mountain. It was really a beautiful thing to see. It looked like one of those dwarves thing from the Lord of the Rings. I don't know if you're familiar.
Very familiar with it. Yes, absolutely. I can imagine it there. Yeah, I'm not the tallest myself, so I might be able to go for a job there as one of the dwarves. Exactly,
we could apply, both you and me. But regarding the power density, I would say we're seeing something. Yeah, as you said, the trend is definitely upwards. I would say most common is around 16, something like that, 16K.
Okay, all right. Yeah, as mentioned with Mare Nostrum, what I found interesting was they had traditional crack units and rear door cooling at the same time. So it was really something to behold, and I know that it absolutely eats a chunk of energy, no matter whether you're somewhere which is slightly colder or not, because there's a lot of parts that are moving there, etc. So again, taking that kind of aspect here just to share with people what we're kind of comparing, and what the average PUE is at today is still, we're at about 1.89 PUE, and that's the power usage effectiveness. I'm sure most of you on this call here are very, very familiar with that. And the high cooling costs that I was talking about, especially with the example of Mare Nostrum 4, where they have dual cooling. So they're using traditional crack units and rear door cooling. So you can imagine it's very noisy. This image, by the way, is not of that particular installation. I have more, but maybe we can save those for future posts, etc. And apart from that, talking about immersion cooling, and today we're not being specific, very specific regarding Submer. We're talking in general about immersion cooling. And of course, it's possible to achieve PUEs of 1.03. And we'll be talking about the space saving, the actual costs, so the economics, where you're spending only 4%. And if you take it that it's, so the 0.3, which is 30 watts per kilowatt, is exactly 4% of the 1.89 PUE. And also we have some silent operation, so it's a totally different environment. Of course, in most supercomputers, which are not immersion cooled, or liquid, be they if they're using some mineral oil, or if they're using a synthetic fluid, or whatever they're using in that regard, you're really talking about that more or less silent operation. So the use case scenario I wanted to touch upon, and Daniele, again, please jump in when you can and when you want, because really it comes down to your own experience, and I'm hoping that you can help to validate a lot of these assumptions. I know we've gone through them before together, However, as well, for the audience, maybe there's a couple of points you'd like to chime in on, but going ahead.
Sure.
So, as I previously mentioned, the fact of immersion cooling and what it can do for HPC is to drastically reduce that energy consumption anywhere. So you were talking about that beautiful installation in Norway, in Ålesund, which is an amazing place, but it is not the nicest weather. I've been there, it's on the west coast of Norway. It gets quite rainy. Yes, they have amazing views, but it's a little bit colder than I would like it, based here in Barcelona. We're also talking about the increase in computer density. And here we talk about per square meter, but it's also per square foot, of course. Also, the fact that you can drastically reduce the building costs. And that has to do with two factors. The fact that you don't need that white space, that data center white space. You can work with raw space with immersion cooling, provided you're working with closed tanks in that regard. And this, the second thing, of course, because you have a larger density, you're also reducing those building costs because there's a smaller area that you have to look after. And last but not least here, talking about reducing the latency, because you're able to have that supercomputer not up somewhere in the north of Sweden, in Iceland, or wherever it may be, but it can be closer to the research center or even on the grounds of the research center or university that you're talking about.
Yeah, and on that regard, I mean, on reducing the amount of cost it takes you to build a facility for such a supercomputer, I would say it's also more convenient, not just if you build a facility, but if you retrofit a facility that's already existing. Because the cluster that we've installed in UK based on this kind of immersion cooling technology, it was not in a facility that was built for that specific purpose. It was just some kind of lab that they were reusing, and it was much easier to just place a couple of tanks of pods in there with submerged nodes instead of trying to adjust the room for raised floors and cable trays on the ceiling and crack units everywhere.
Okay, that's a topic we're going to come back to in a couple of seconds here. I just want to get started into, again, what we were talking about with this particular use case, where we're talking about a theoretical exaflop supercomputing facility. The one we're talking about here today in immersion cooling, we have calculated it at approximately 233 square meters. And I'm basing the theoretical exaflops on 17,600 NVIDIA T4 GPUs. Also, there's 2,200 CPUs. We're not super interested in them here today. I know that some of you may have some questions on them. The reason why I've taken a T4 and maybe not something else like a Titan, which actually promises much higher teraflops, is because these T4s are data center rated cards. They're also fairly low power. So they are somewhere in the region of somewhere between 75 and 100 watts, as far as I know. And I know that plenty of hardware manufacturers either have or are working on 16 GPU 2U format servers, so that you can really fit this amount in like quite easily. Let's just take that mixed number of 65 teraflops, just so we have this calculation for today. When we're talking about the energy costs, and really here, this is just a simple calculation of saying, what does it cost in different countries to power 10 megawatts of compute in this regard per year, or in this case, over 3 years as well. So what I've done here is taken the average energy cost that we have available in Europe. I know the span is huge. You can get 5 cents per kilowatt hour. You can get 29 and 30 cents per kilowatt hour in Germany and in Denmark. In the UK, the average is 12.5 pence per kilowatt hour. Of course, again, there are many options to get more expensive or cheaper, but the average there is actually a tiny bit lower in that regard. And in the US, again, the same as possible, anywhere between 5 cents per kilowatt hour or going up to 20 cents per kilowatt hour. It really depends. So just giving you this particular example, and I thought I would just give you the simple calculation, just so people can imagine the following, where we talk about powering 10 megawatts in a liquid immersion cooling scenario where you're really not spending an extra almost 10 megawatts in the cooling of it, but the difference is here that you're talking in Europe about 13.8 million euros per year. And if we look down to what that actually saves over 3 years, so 36.9 million over 3 years in this regard, you can all imagine whether we're talking about savings of 30 million pounds, euros, or dollars over the course of 3 years. The way that budgeting works for HPC, it means that these energy costs are going to form a significant part of that budget. And if you can take that budget and you can actually invest it in either better quality hardware or more hardware, then this is something that is going to put you higher up on the top 500, etc. Daniele, please just confirm my logic is okay so far. We're good.
Completely agree with that. I would also add that even if you were able to get power for free to power your own facility in some way, I mean, with the amount, with the increase in TDP that we're seeing in recent years, we're already at the border of what can be cooled with air efficiently.
Moving on then to the next vector that we were talking about, and we're talking about the compute density. And with regards to immersion cooling, and if we talk about the possibility right now today, I know we've seen maybe some a little higher. I'm communicating from my side a density possibility of 104 kilowatts per square meter, or 9.66 kilowatts per square foot. The actual density represented in this particular example is actually about 51.1 kilowatts per square meter, or 4.75 kilowatts per square foot. And it gives us something like 2.2 to 2.4 kilowatts per U. So just taking this into account, I know here at Submer, and I know also with lots of other competitors, we are all working on increasing that density. And I know from our side, we're working well above the 150 kilowatts in our labs, but for today with commercial, this is what we have. When we talk about the land costs, and I know this is something which people can really dispute in different countries. I don't want to enter into a dispute, but just to give people the idea of the size of land that I was talking about. So 233 square meters, which is 2,500 square feet. We are talking about an average purchase price then, if we take 2.5K pounds, euros, or in the US, land prices tend to be a little bit cheaper, especially in more remote locations. More land available, I guess, is one of the main reasons, where we're talking about $1,700 per square meter. When we compare that to an air-cooled environment, we really are also talking about significant savings. And again, you know, this is just really the difference, and I really want to get that message across to everybody, that immersion cooling, in whatever form it may be, is the way forward for HPC in future, where we're really talking here of budget savings of 1.7 million euros or pounds, or just over $1 million in US dollars here. Of course, this is if you're going to acquire that particular land. Now, there are going to be other rooms associated. You are going to have some kind of knock. You're going to have some other things outside of it. But I just wanted to focus on this particular space here. Again, this is one of the things, Daniele, you were mentioning earlier regarding the raw space versus white space. And if we think about it, raw space, and to prepare raw space for immersion cooling, your costs are going to be much, much lower than if you're preparing any kind of white space. So, you know, again, putting those savings here just down there, we're talking about 2.9 million euros, 2.5 million pounds, or just over 3 million US dollars. Another very, very compelling argument again here. These are things that can go back into your budget, either for attracting maybe people of a higher caliber, not casting any aspersions on anyone, but I know in academia and in the world of research, it is sometimes hard to attract talent unless you're one of those top tier research centers and you're able to command those higher salaries. The last vector here is the deployment speed. And maybe, Daniele, from your side as well, we talk about containerized HPC, where we know that we're able to deliver something 3 months from order to delivery. What's been your experience so far with anything either containerized or, as you said already, reusing existing space?
Well, unfortunately, I don't have any experience with containerized equipment, but reusing existing space is something that happens very frequently. I mean, not even at large scales, but there are people in small research center that happen to have a room that's not used for anything, and they just end up fitting their equipment in there, which is of course creating all kinds of headaches, because the room is not meant to be hosting machines, so it's usually closer to other people working, and they complain about the noise, and then the air is not filtered, so they just take a normal air conditioning unit, the one that you would use in an office, and they crank it up to 11, and they pretend that's good enough to cool these machines. So the machines are getting dirty air, they're getting cooled properly. So also in those cases, I think a completely sealed container with immersion cooled servers would be of much more advantage, and would provide more comfort also to the people that are going to sit around this reclaimed space.
Okay, yeah, I mean, from our side, and I'm sure a lot of you listening and taking part can also concur, that we're involved in some projects, some of which are more traditional data center like environments, others which are maybe more akin to raw space, and we are also involved in several containerized HPC projects as well. The containerized story means that you can actually prepare everything prior to deployment, and it's just a case of connecting it to power and connectivity once you get it there. What I really wanted to summarize here in this regard, the 10 megawatt facility, which I introduced at the beginning, in this scenario here actually translates into 5 megawatts. Because if you take my scenario where I'm talking about per square meter, or also in this case where we're talking about around about 49 kilowatts in each one of these pods, which you're looking at here, it means that in order to deliver exascale in that 233 square meter space, you really are talking about 5 megawatts, not 10 megawatts. Daniele, so, the ease of implementation, I really want to ask you in particular regarding immersion cooling. So how have you found it with regards to IT hardware and the ease of implementation?
Well, in our case, I think we complicated our lives a bit, because we went for custom designed metal plate on which to fit the motherboards. So we were not using completely off the shelf components, just taking out the fans, of course, and the few bits that are not supposed to be submerged. But in that sense, it allowed us to be a little bit more dense, because we were able to fit something like 50, 60 machines per tank. I don't really remember the number, but something along that way. And which, of course, it's because, of course, a motherboard mounted on a metal plate doesn't occupy the same space that the whole enclosure would. Mm-hmm. But in that particular situation, we had to manufacture the plates, and we had to fit the motherboards ourselves. So it was a little bit of an extra work, let's say. But it can be done also in other ways. So it doesn't have to be so complicated. That's what.
Yeah, maybe just on that. We are working with a number of hardware providers today, a number of OEMs. They provide hardware which is already ready for immersion cooling. And that is the hardware that we're going to be using in many of these projects. I'm not going to go into too much detail on that there, because that's actually going to be more or less content of our next webinar. But then how about the other hardware? So I'm talking about the actual physical tanks themselves and any other bits and pieces. How was that in comparison to a traditional HPC implementation?
Well, there were less moving parts, which is always a good thing, less things that can fail. And the tanks in the cases that I was familiar with, they were really simple. That there was no logic involved. There were just a couple of pumps circulating the liquid, but it was pretty well thought out.
Okay, cool. The last consideration was something that I threw in here. It's probably completely nonsensical, but software-wise, I presume there's absolutely no difference whatsoever in the software that you'd be using.
That's right. There was no difference. So the only, maybe if we want to cite one, it's that we usually implement some kind of safeguards in order for the machines to shut themselves off should they be overheating. And we were extra cautious in setting those thresholds really in a sensitive way, I would say, in those cases, because if the oil were to run low, we would have risked completely frying the hardware in that sense.
Okay, interesting. So I can take it that you absolutely, the two installations that you worked with were using mineral oil and not a synthetic fluid as we use. Is that correct?
Mineral oil, that's right.
I'm kind of being very daring in asking you this, and please, I want you to answer it completely honestly. So, you know, I want to make people aware and share with them the value of what are the possible challenges of immersion cooling in this specific scenario, because I mean, surely there must be some challenges.
Sure. I mean, people are not familiar with this, and this is, I think, the main challenge. We need, if we want this to be able to take some space in the HPC realm, we need to educate people that submerging servers is not the end of the world. The servers are not going to be lost after that, and also we need to teach them how to operate a system like this, because it's not what they are used to. So they need to learn a new way of working with this kind of submerged hardware. It's way different than extracting a blade from a rack, instead having to pull out the machine from whatever liquid it is, letting it drain for a while, and then servicing it in a way that doesn't spill everywhere. So there is a lot of education to be performed, a lot of formative probably sessions to be had for whoever is going to be involved into taking care of one of these systems.
Just maybe you could just really briefly outline to us, for somebody who may be a HPC engineer who's in this call, who's used to doing any kind of maintenance in air, and you just want to either assure them, or what are the main differences between that and liquid?
Oh, let's say I have to just replace a memory module. If I had to do it in air, I would just either take the machine down or take it out of the rack and then replace it straight away. That's an easy thing to do, and then you just put it back when you're done. But if you have to do the same thing on a submerged system, especially if the system, well, in one of the cases that I was citing before, our customized metal plate had 2 motherboards per plate, which meant that every time we wanted to take out one of the plates, we had to take off 2 nodes from the queue. So 2 nodes were not available anymore for the users, and maybe the second node didn't need any physical attention in that particular case. So sometimes we had to wait until the other node got drained as well. But coming back to your question, the point is that you have to take the machine out, and probably you have to let it drain for a while. So you cannot perform your changes straight away, unless you have some kind of harness that lets you hang the machine on top of the pod of the tank, and then you can perform your changes while the machine is hanging on top of it and just dripping a little bit of liquid back in the tank itself.
Okay, so yeah, it's something which requires accepting that it's a little bit different, but you know, again, we have to accept changes, and eventually taxi drivers have to accept Uber and everything else in that regard.
Exactly, okay. But everybody who was operating these kind of machines, they didn't know how to do it before. They had to learn. So it's just a matter of learning something different.
Okay. I wanted to share with you and also with everybody out there some of the tests that we've been doing in air and in liquid. So just to share the conditions with you here, I've just taken one particular CPU core just to keep it pretty simple so we can see what we're talking about. And here we have a set point in the bath, in the tank, of 50 degrees centigrade for the liquid cooling. For the air, we're talking about a standard data center environment which has an ambient temperature of 20 degrees, which is being fed by crack units in that regard. And yes, we are talking about a densely packed scenario. So a lot of people think that with immersion cooling, that actually your processors and your GPUs will be running hotter than they do in air because we talk about a higher set point. However, this is not the case. We see that the temperatures reached in air in this regard, this is under 100% load, are up there in the high, let's say mid 70. These are all in Celsius. And here we're seeing in and around anywhere from 49 to 52, 53 degrees then in the liquid. And one of the things is that because the liquid temperature is 50 degrees at the top, and I'll just show you a visualization of that in just a moment. I promise to share some of that. It really means that we're keeping those temperatures as close as possible to the liquid temperature. I also wanted to share here some results that we've had. In this case, this is an 8 GPU 2U node. And I wanted to share the temperatures that we have both below, so here down below, and between the GPUs which are up higher. So if you imagine those that are up higher are going to be in a higher temperature zone in the liquid itself, and the lower ones are of course in a lower temperature zone. And once we go into the visualization, we'll be able to see that a little bit better. But here, these were with NVIDIA Tesla K80s, and you can see that the lower nodes, that the average that the lower GPUs, pardon me, that we're talking about are in the 46 to 47 degree centigrade range. They're of course down in liquid, which is a little bit lower in temperature down there. And then up higher where the temperature is nearing or in and around 50 degrees, we're seeing here just about a 2 to 3 degree difference then between the placement. So as probably all of you will know, and probably know far better than I, GPUs, CPUs, they of course throttle back when they're reaching higher temperatures. And we've seen certain GPUs, Teslas, that start to throttle back at about 70 degrees, 72 degrees. And in this case here, it means that it opens the world of overclocking and really getting that extra 20, 30% out of your installation. I did want to show the thermal pictures here as well. I'm hoping that you can read this here. This is in Kelvin. We are talking about at the top here, so 323 is about 50 degrees. And then down below here, the 311, we're talking about 37 degrees, something to that effect. Here we have the liquid. This is the visualization of the liquid and how those temperatures are flowing. And you can see that, which is hotter and which is then where you have the colder with the changing colors. And of course here, this is on the actual heat sinks of the GPUs and of the CPUs in that regard. And here, I just want to share this visualization with you, which is, again, something which you're very familiar with, seeing as this is what you started off with, Daniele, with the CFD, where we're showing how it is that we flow and actively move this liquid in and around the hardware in order to ensure as harmonious a temperature as possible, or homogeneous. And where you see here at the bottom, this dark blue, that is about 37 degrees centigrade. And then here, these red arrows here, they are approaching 50 degrees. It's really a span of 13 degrees centigrade in total. That's that particular one. And I also did want to share it with you side on as well, so that you can see this here, which I hope is coming through here. So I just wanted to give you the view here. And of course, this particular thing here is with Submer. So you see here where the heated fluid is being then drawn into the overflow, and then where the heat is going to be exchanged with a secondary cooling loop, which is generally a closed water loop. We have next time around on the 5th of March, a very, very special guest, Alain Wilmuth from 2CRSI, a very good hardware manufacturing partner of ours based in France and in the US. They manufacture hardware also specifically for immersion cooling. And this is something which is very exciting, which could come in useful in projects like you were discussing, where you wouldn't have to mount yourself on plates. Everything comes pre-prepared. And this particular session is going to be very interesting because they'll be going into the design considerations for immersion cooling. And that'll be together with Daniel Pope, the CEO of Submer, who will be the host in that regard. We'll do the same time again. This time it's going to be Tuesday, the 5th of March. I have here a question. The issue with our client, they said the cabinet comes with the servers inside, and if we take it out, the warranty will end. Do you have any agreement with vendors such as Oracle, EMC, etc., that you can remove the servers from the cabinet and the warranty will stay valid? Daniele, if you would like to have a quick crack at that, especially regarding immersion cooling, what is your experience regarding warranties? And then I'll get into an answer.
I think it has to be negotiated between the integrator and the supplier of the hardware. The way that we did it back then, since we, as I said, mounted most of it by ourselves. So we were also having some kind of agreement with Supermicro, which was providing the hardware in a way that they got the motherboards back for RMA whenever we extracted them from the oil.
Okay. One of the things from our side, so either people can work with hardware manufacturers like 2CSI, who of course provide such warranties in immersion cooling, or in other projects we are working together with a whole host of hardware manufacturers such as IBM, Lenovo, Gigabyte. They're probably some of the main ones, but also with Inspur. And these people provide warranties for immersion cooling, of course, provided you're working with their product teams, etc. But really, at the end of the day, don't forget, please, HPC people, what you're generally ordering hardware-wise is not a small order. It's a multi-million order, and you have a position with these manufacturers where you are able to leverage and say, guys, we need this to be supported because it's so much more efficient. We don't want to go down the traditional route with you. And really, it is not that much trouble for people like that to prepare hardware for immersion cooling. And in our experience, it's been quite a pleasure to work together with certain manufacturers. Others have been a little bit more difficult, especially maybe the more traditional ones. However, this is definitely the case. Where are you at the moment?
I'm at the Observatory Lakota in Nice.
Okay, and is there anything you can share with us about that project?
Well, they could use, I mean, they used one machine room that wasn't supposed to be a machine room at all. It was, I think it used to be a classroom. So talking about reclaimed spaces, which means it's very close or not very far from the offices of other people. It's exactly the same topic that I was exploring before. I think it would be much easier for people to work nearby something that's not as noisy as this thing is. And it's also much more comfortable. You were mentioning before that it's the striking fact about working in an immersion cooled system is how silent it is. But there is another point which you didn't mention. It's the fact that whenever you work in a conventional machine room, you end up being moving from the hot aisle to the cold aisle, and it's not very comfortable for anybody to spend a long amount of time in there. Whereas with an immersion cooled system, you don't have this kind of variation in temperature, and you can easily work in your t-shirt and not feel any kind of temperature discomfort.
Okay, I must admit that's not something that I ever thought about, but that tells you how much physical time I spend in cold aisles, etc. So, because for me, like, this is now the new normal, and I think for a lot of people, it's going to be the case. I want to share with you where Submer is going to be and where you can meet us over the coming months. We're, of course, in our native Barcelona at the Mobile World Congress between the 25th and the 28th of February. Everybody's very welcome if you're taking part in that. And also during that period of time, you can organize trips to our facilities, etc. We'd be very happy to do so. We are going to be at the Green Data Center Conference in San Diego, which is also during the same time, more or less, where we'll be represented by Jeff Brown, our new Managing Director of North America, and some other members of the team. Again, here with regards to the Oil and Gas HPC Conference in Houston. We're also at the in Japan. There's so many things happening in March. It's a little bit crazy. Data Center World in London. we're represented both in the innovation space and also on the exhibition floor. And now one of the absolute key events for us, I have to say, is this OCP Summit in San Jose in March. That's where we're going to be making also a big product announcement. So anybody who's going to be there, please make sure that you look us up. There's another question after coming in. Somebody would like to know if we have ever worked with HPE. And another question, can you explain what kind of IT hardware would not work with your kind of liquid? So a two-part question, have we worked with HPE? We've worked with HPE, but because we are still working with them and their product management, we step up and provide the warranties ourselves through a third party, which is something that we can do. Now, what kind of IT hardware would not work with our kind of liquid? Really, it's very simple. It is no fans, because otherwise you're wasting energy completely, and no other moving parts, so no spinning discs. So everything would be solid state. And apart from that, another thing that we do is that we remove anything like a thermal paste from any CPUs or GPUs, because it's something that would just get suspended over time in the liquid. And we replace that with indium foil. However, I do know that some of our partners, and especially in the next session from 2CRSI, this consideration will be discussed, because 2CRSI are today applying a special type of thermal paste, which is not only compatible, but works extremely well also in that liquid environment. On that particular note, Daniele, I would like to sincerely thank you for all of your insights and for joining us here today.
Thank you very much for having me.
And to everybody out there, thank you so much.